Intermittent electrical problems such as flickering lights and power outages can be frustrating to diagnose. Several factors can contribute to these issues, and a systematic approach is necessary to identify the root cause and implement effective solutions. Let's explore some potential causes and troubleshooting steps. Firstly, loose or corroded connections are a common culprit. Check for any loose or corroded connections at the panel, outlets, switches, and fixtures affected. These connections can degrade over time due to vibration, temperature changes, or improper installation. A loose connection increases resistance in the circuit, which can lead to voltage drops, flickering lights, and even complete power loss. Corrosion can further exacerbate this problem by creating an insulating layer that impedes current flow. Secondly, a ground fault can also cause intermittent power loss. A ground fault occurs when an uninsulated live wire comes into contact with a grounded surface such as a metal enclosure or a grounding wire. This creates a low resistance path for current to flow, resulting in a large current surge that trips the circuit breaker or blows a fuse. However, in some cases the ground fault may be intermittent, causing the power to flicker or go off and on. Inspect wiring and connections for any damaged insulation or ground faults. Look for signs of exposed wires, cracked insulation, or moisture near electrical components. Thirdly, a defective circuit breaker or fuse. Even if there are no trip breakers or blown fuses, one of them could be faulty. Circuit breakers and fuses are designed to protect electrical circuits from overcurrents. Over time, these devices can become worn out or damaged, leading to intermittent tripping or failure to trip when needed. This can result in flickering lights, power outages, and even electrical fires. Replace the suspected breaker or fuse with a new one of the same amperage rating. Fourthly, arcing between wires or components can cause intermittent power loss and flickering. Arcing is a phenomenon that occurs when electricity jumps across a gap between two conductors. This can happen due to loose connections, damaged insulation, or the presence of conductive dust or debris. Arcing generates heat and light, which can damage surrounding materials and create a fire hazard. Check for any evidence of arcing or burnt insulation. Look for signs of blackening, melting, or discoloration around electrical connections and components. Fifthly, ground fault circuit interrupters, known as GFCIs, can trip even when there is no actual ground fault. GFCIs are safety devices that are designed to protect people from electrical shock. They work by monitoring the current flowing through the hot and neutral wires of a circuit. If there is any difference between these currents, it indicates that some current is leaking to ground, which could be through a person's body. When this happens, the GFCI trips, cutting off the power to the circuit. However, GFCIs can also trip due to nuisance tripping, which is when they trip even though there is no actual ground fault. This can be caused by electrical noise, voltage fluctuations, or defective GFCI devices. Reset any affected GFCIs by pressing the reset button on the device. Sixthly, overheating wires or components can cause wires or components to overheat and malfunction. Heavy loads or poor ventilation can cause wires or components to overheat and malfunction. When electrical conductors are overloaded, they generate excessive heat due to the resistance of the wire. This heat can damage the insulation surrounding the wires, leading to short circuits, ground faults, and even fires. Poor ventilation can exacerbate this problem by preventing heat from dissipating properly. Check for any signs of overheating, such as discolored insulation, melted components, or a burning smell. Now let's discuss how to solve these electrical issues. Firstly, inspect connections by checking and tightening all connections at the panel, outlets, switches, and fixtures affected. Use a screwdriver or wrench to tighten any loose screws or nuts. Be careful not to over-tighten them, as this can damage the components. Secondly, rule out ground faults by using a multimeter to test for continuity between the neutral wire and ground. Continuity is a measure of how easily electricity can flow between 2 points. If there is continuity between the neutral wire and ground, it indicates that there is a ground fault that needs to be repaired. To perform this test, turn off the power to the circuit and disconnect the neutral wire from the neutral bus bar in the panel. Then, set your multimeter to the continuity setting and touch one probe to the neutral wire and the other probe to a known ground, such as the metal enclosure of the panel. If the multimeter shows continuity, it means that there's a ground fault somewhere in the circuit. Thirdly, replace a faulty circuit breaker or fuse. If you suspect a faulty breaker or fuse, replace it with a new one of the same amperage rating. Before replacing a breaker or fuse, turn off the power to the circuit at the main panel. Then, remove the old breaker or fuse and install the new one. Make sure that the new breaker or fuse is properly seated in the panel. Fourthly, investigate arc faults by looking for any signs of arcing, such as burned insulation or melted components. If arcing is suspected, isolate and repair the affected section of wiring. Arcing can be difficult to detect, as it often occurs in hidden locations. However, there are some telltale signs that you can look for, such as a burning smell, flickering lights, or unexplained power outages. If you suspect arcing, turn off the power to the circuit and carefully inspect the wiring and components for any signs of damage. Fifthly, reset GFCIs. If any GFCIs are tripped, reset them by pressing the test and then reset buttons. GFCIs are designed to protect people from electrical shock, so it is important to reset them as soon as possible after they trip. However, if a GFCI trips repeatedly, it may indicate a more serious problem that needs to be investigated. Sixthly, check for overheating. Feel for any warm wires or components. If overheating is suspected, reduce the load on the circuit or improve ventilation. Overheating can be caused by a number of factors, such as overloaded circuits, loose connections, or inadequate ventilation. If you suspect overheating, turn off the power to the circuit and carefully inspect the wiring and components for any signs of damage. Reduce the load in the circuit by unplugging some appliances or turning off some lights. Improve ventilation by ensuring that there is adequate airflow around electrical components. While troubleshooting electrical problems, always observe safety precautions. Always turn off the power before working on electrical components. This is the most important safety precaution to take when working on electrical systems. Turning off the power will prevent you from getting shocked or electrocuted. Use caution when testing for live wires or continuity. When testing for live wires or continuity, use a multimeter that is rated for the voltage that you are testing. Also, wear insulated gloves and safety glasses to protect yourself from electrical shock. If you are not comfortable troubleshooting electrical problems, contact a qualified electrician for assistance. Electrical work can be dangerous, so it is important to hire a qualified electrician if you are not comfortable doing the work yourself. A qualified electrician will have the knowledge, skills, and experience to safely and effectively troubleshoot and repair electrical problems. Remember, electrical safety is paramount. If you're uncertain about any aspect of electrical work, it's always best to seek professional help. A licensed electrician can diagnose the problem accurately and perform the necessary repairs safely, ensuring the well-being of your home and family. By following these steps and prioritizing safety, you can effectively troubleshoot and resolve intermittent electrical issues.